Welcome, everyone. Thank you for being here today. I'm excited to introduce our topic, maintenance management strategy. On this first slide, we'll set the stage for our discussion. Our goal is to build a maintenance strategy that aligns with the PMP stages: initiation, planning, execution, monitoring, and closing. We'll focus on ensuring safety, efficiency, and cost control throughout the process. Over the course of this presentation, we'll explore how to develop and implement a strategy that meets these objectives. So, let's get started. Now, let's take a closer look at our PMP approach for maintenance projects. We're applying the PMP methodology specifically to operations and maintenance, or O&M projects, which include systems like HVAC, plumbing, civil works, and standby systems. The first phase is initiation, where we clearly define the scope of the project and set the boundaries for the services we need to deliver. This step is crucial because it sets the foundation for everything that follows. Next is planning. In this stage, we develop preventive maintenance plans, create risk logs to anticipate potential issues, and build resource matrices to ensure we have the right personnel and materials in place. This structured planning helps us stay proactive rather than reactive. Then comes execution, where we put our plans into action. We implement project management checklists to keep tasks on track and safety permits to ensure a safe working environment for everyone involved. Following that is monitoring. Here, we track key performance indicators, or KPIs, using dashboards. This allows us to monitor progress in real time, identify any deviations early, and make necessary adjustments promptly. Finally, we reach the closing phase. We document lessons learned to improve future projects and compile comprehensive maintenance reports that summarize what was achieved and what needs attention moving forward. For tools, we rely on MS Project to schedule and manage tasks efficiently, and Power BI dashboards to visualize our KPIs and project data clearly. All of these steps work together to ensure our maintenance projects are well managed, safe, and aligned with overall operational goals. Now, let's talk about our electrical maintenance strategy. The scope here includes key areas like the substation, lighting fixtures, and sockets. To keep everything running smoothly, we rely on a computerized maintenance management system, or CMMS, which helps us schedule preventive maintenance tasks proactively. This way, we can identify potential issues before they become serious problems. We also use thermal imaging technology to detect hot spots, which can indicate faulty connections or overloaded components. Catching these early is crucial for safety and reliability. For diagnostics, we typically use tools like multimeters and power analyzers to measure electrical parameters accurately and troubleshoot effectively. Safety is a top priority, so we incorporate lockout/tagout procedures into our process. This ensures that equipment is properly de-energized and protected during maintenance, preventing accidents and ensuring compliance with safety standards. The ultimate goal of all these measures is to minimize downtime, keeping our operations running smoothly, and to ensure compliance with electrical safety standards like IEC and NFPA 70. By integrating these strategies, we enhance both the safety and efficiency of our electrical systems. Now, let's take a closer look at our mechanical maintenance strategy. This covers a broad scope, including HVAC systems, pumps, tanks, exhaust fans, and drainage systems. Our goal is to ensure these components operate efficiently and reliably. We're implementing vibration analysis and oil monitoring specifically for rotating equipment. These techniques help us detect issues early before they become major problems, which is crucial for maintaining system health. Additionally, we're integrating SCADA and BMS systems to optimize runtime. This means we can better control and monitor equipment operation in real time, reducing waste and improving performance. We're also leveraging smart sensors, or IoT devices, to enable predictive alerts. These sensors can detect subtle changes that might indicate potential failures, allowing us to address issues proactively. Ultimately, the main goals here are to reduce energy consumption by 15 to 20%, and to increase the mean time between failures, or MTBF. This approach not only enhances efficiency, but also extends the lifespan of our equipment, supporting our overall operational excellence. In this slide, we're focusing on our civil and plumbing maintenance strategy. The scope covers essential areas like painting, carpentry, welding, and plumbing networks. To manage these effectively, we're implementing a digital permit system, which helps us ensure safety and proper work sequencing. This system allows us to coordinate tasks smoothly and reduce risks on site. We're also using 3D BIM inspection sheets to monitor finishes and identify defects early. This 3D modeling provides a clear visual of the work and helps us catch issues before they become bigger problems. Additionally, AutoCAD combined with checklists is used for corrective works, making sure any defects are addressed systematically and efficiently. The main goal here is to achieve sustainable finishes, meaning long-lasting, quality results, and to eliminate repetitive defects, which can cause delays and increase costs. Overall, these strategies are designed to improve quality, safety, and efficiency across our civil and plumbing maintenance activities, aligning with our broader aim of delivering a superior project. Now, let's take a closer look at our integrated maintenance plan for all trades. The structure is built around a unified maintenance matrix that combines electrical, mechanical, and civil maintenance activities into a single, comprehensive framework. This integration helps ensure that all aspects of maintenance are aligned and coordinated effectively. We've also implemented a priority classification system to prioritize tasks. A for critical issues that need immediate attention, B for medium priority tasks, and C for routine maintenance. This classification helps us allocate resources efficiently and focus on what matters most at any given time. Coordination is key in this plan, so we hold daily toolbox meetings to review ongoing tasks and address any immediate concerns. Additionally, we track everything through our computerized maintenance management system, or CMMS, to keep all activities organized and transparent. To support real-time decision-making, we've integrated tools like Power BI and an Excel dashboard. These provide us with live KPI views, allowing us to monitor performance constantly and respond swiftly to any emerging issues. Overall, this integrated approach ensures that maintenance is proactive, well-coordinated, and data-driven, which is crucial for maintaining optimal operational efficiency across all trades. Let's take a closer look at performance indicators and reporting. Here, we focus on some key KPIs that help us gauge how well our operations are running. First, the PM completion rate, expressed as a percentage, shows how effectively we're completing our planned maintenance tasks on time. Then, we have the mean time between failures, or MTBF, which measures the average time between equipment failures. This helps us understand reliability over time. Response time in minutes indicates how quickly we respond to issues when they arise, reflecting our agility. Lastly, the Energy Efficiency Index, measured in kWh per ton, gives us insight into how efficiently we're using energy relative to production output. And to tie it all together, we utilize a Power BI dashboard that's automated with data links from Excel and SharePoint. This setup allows us to visualize these KPIs in real time, making performance tracking seamless and accessible. Overall, these indicators and tools are vital for continuous improvement, helping us stay aligned with our operational goals and ensuring we deliver optimal performance across the board. Let's talk about continuous improvement and sustainability. This is all about embedding a mindset of ongoing enhancement into our maintenance culture. First, we'll implement Kaizen and lean maintenance principles. These approaches encourage small, continuous changes that add up to big improvements over time, making our processes more efficient and waste-free. Next, we focus on conducting root cause analysis, or RCA. This means digging deep into problems to identify the true underlying causes, rather than just addressing surface issues. By doing so, we can develop effective solutions that prevent recurring problems and improve overall reliability. Training is another critical component. We're investing in equipping our technicians with the latest safety practices and AI tools. This ensures they have the skills and knowledge to work safely and leverage advanced technologies for smarter maintenance decisions. The ultimate goal here is to foster a smart, predictive maintenance culture. By doing so, we aim to reduce corrective work by 30%. This proactive approach not only minimizes downtime, but also supports our long-term sustainability efforts, making our operations more resilient and environmentally responsible. So, in essence, this slide highlights how continuous improvement initiatives, combined with a focus on safety, technology, and root cause analysis, will drive us toward a more efficient, predictive, and sustainable maintenance environment.